Hello everybody! If you just came here from the main channel video where I talk about whether outlets should be considered upside down when they're like this, hello. If you haven't seen that video, you might want to check it out. There's a clicky thing. But this video is going to be about tamper-resistant receptacles because I had originally included a section in that script about them, but I decided I'd better run to the store, pick some up, and do a sanity check to make sure that what I was saying is true. And it wasn't. So I removed it from the script and I'm just going to talk about it here. So these things that I teased at the end, said you could pick up some of these are blanks. So they're just plastic covers that you stick over outlets to prevent your toddlers from sticking stuff into them. And they only work for so long because eventually your toddlers grow up, become curious weirdos, and stick screwdrivers in them, like I did. But nowadays, I don't know how long this has been code, but it's been some time. New homes are going to be built with tamper-resistant outlets at the heights, at least, where children can reach them, or they're easily accessible. Now, a tamper-resistant outlet is very similar to the long-standing British outlet in that we now have shutters over the live and neutral pin. So this is a tamper-resistant outlet here, and usually they'll be marked TR on the well, depends on the design. This one has a TR marking on the face, but it's beneath the wall plate, so you won't see it. Some of them it will be on the somewhere that you can see it. Other times, like this one, it's not listed anywhere. But on the packaging, this TR logo, that is what indicates they're tamper-resistant. And so we now have shutters behind the live and neutral blades, which prevent you from sticking stuff in them. Now you might ask, because we don't, unlike in Britain where every cord has 3 prongs, most of ours don't have 3 prongs. There's many appliances that don't need to be grounded. So how do we deal with that? Well, this shutter mechanism, it has to be, oh right, sorry, because in Britain you use the longer ground pin, that's what opens the shutters. So you need to be sticking something in the ground pin for those shutters to open. We arguably have an even better solution because now you have to press both the live and neutral pin simultaneously for those shutters to give way. So it's actually quite tricky to defeat this because you need to poke 2 things in at the same time in order for those shutters to actually open up. The only downside is when you're using these day to day, if you haven't run across these yet, they can be kind of weird because if you don't have the plug straight on, if you have, the neutral pin pressing in proud of the hot pin, it's not going to let you insert it. You need to make sure that you're going straight in. So they're a little bit weird if you're not used to them. But, so the assumption was, because I've run across this before, I have used some tamper-resistant outlets where the bite point is much deeper. So the outlet is not actually holding on to those blades until it's much more inserted. There's probably maybe only 5 millimeters of gap, maybe not even, but there's only about 5 millimeters of exposed blade with that design. Whereas with a non-tamper resistant, you might have like 8 or 9, maybe even a full centimeter, depending on how bad the design is. So I had assumed that the bulk of the shutter mechanism was what was causing that, because presumably there's something now behind this face that's going to make the body thicker, so the contacts inside the outlet are probably a little bit more recessed. But I ran to the store, got a couple more, and tested them. Neither of the 2 that I tested are any better. And it turns out that's because the shutter mechanism is incredibly flat. This is all that it is. And it has something to do, I think it's, because what happened, you can see on it, as you may be able to tell, this was very destructive. I did not use a Dremel tool. I thought I could just break it apart. Should have stopped and moved to a Dremel tool, but stubborn persistence kicked in and I just went at it with a couple of vice grips. But this thing here is all that it is. There was a spring in the center, and so what I believe is the case is that it's really just blocking, because it slides, put it that way. It slides out of the way. And with the way the spring is arranged, if it's pushed in this direction, this will move and catch whatever's trying to push it. and if it's pushed in the other direction, the spring tension will not allow it to move. I don't quite have my head around how this works. I haven't looked at patents or anything. But the point is, it's a very, very slim mechanism. So neither of these two are any better as far as a partially inserted plug. They don't solve that problem at all. I have run across some that make it better. They still don't solve it. But you can't have quite such an extreme sticky outy bit go live. Very technical language here, but the bigger thing is, like, as far as holding the plug wrong, you have to really be holding it wrong with some of the new tamper-resistant designs, but not these. These two, the shutters, they do their job of preventing someone from sticking a screwdriver or one single thing into the live and neutral blades, but they do not make an actual plug any safer to use because they're just not. So I rigged up I tested it with a multimeter, put it on continuity, one end of a power cord, the other end in the hot terminal, and as you can see here, it starts beeping way before the outlet is anywhere near fully seated. So plug, I mean, is fully seated. So it doesn't fix that, which is a bit of a bummer because that was a bit of an opportunity. However, the newer or the alternative design I've run across that only grabs on to the very tip of the blades, well, I can see that becoming, I don't want to say problematic. I would imagine that design wears out faster than this. I've gone over this. Part of what I wrote in the original script is because I keep seeing from Europeans and other people who don't live in the US, and they're like, your plugs are constantly falling out. And I'm always like perplexed by what they mean, but I think they mean the partial now anyway. I think what they mean is what we were just going over, that sometimes they back out a little bit and then they're not, that there's a bit that's exposed. However, and I know I talked about this before somewhere, particularly in hotels, the sort of receptacle that's not built into the wall, but gets put in like a lamp base or even a power strip or something that's like on the desk, those are not built to the same standards as what goes into your walls. And they do wear out really fast, especially because it's in a hotel. People are plugging and unplugging things routinely. Anyway, where was I going with that? So the whole thing about your plugs are always falling out. I've never really understood that complaint. If you mean they can become partially dislodged and there's access to the hot pins, then yeah, they're bad. I know they're bad, but I've always been perplexed by your cords are always falling out thing because I don't quite get that. Yeah, I've lived in plenty of old places with very old receptacles. Actually, not related at all to the topic, but if you ever want to do a pretty cheap and easy home renovation, replace all your outlets and your wall plates. It's not that difficult. I know it's going to be scary for some people to do, and maybe you live somewhere where even that kind of electrical work is illegal for a homeowner to do. But assuming it's not, you can pick up contractor packs, get a whole bunch of these. You can impress a house inspector by going to tamper-resistant outlets. They're not much more expensive, especially when you buy a multi-pack. And when you change out the outlets and wall plates, it makes a huge difference because, they start to get dingy. They do wear out. You can tell, they get scratches. Oftentimes they get paint on them because people are lazy when they paint. So that's a good thing that you can do if you are up to it. But don't ask me for advice on how to do it. You got to learn that yourself, okay? So since this is probably going to be pretty heavily edited, since I'm all over the place and didn't organize my thoughts here at all, I just started recording at the end of the main channel video, the outlets do wear out, but usually it's like decades later, unless it's in daily use and it's a poor design. So the new design that I was talking about, or the alternative tamper-resistant design that's only holding on to maybe the last 5 millimeters of the blade, that might wear out faster than this. So it could be a pros and cons type thing. This design certainly doesn't alleviate that particular risk, but it also doesn't fundamentally change anything about the receptacle. So I would expect this to last just as long as any other. Especially because this one, I believe, was commercial, right? Yeah, they're built to slightly different standards. There's some people who on YouTube who actually tear outlets apart and take a look at some of the how well different ones are built, and there's a whole bunch of discourse I don't want to get into there, because you talk about the people who generally, like these ones have a place to backstab the outlet. You can just strip a wire and shove it in there. Almost everyone says never do that. I'm not sure I agree fully. I would not do it if we were daisy chaining outlets, because then this is not as good a connection as the side terminals. But like, if this is the end of a branch or you've done your electrical in some other way, I wouldn't necessarily be too worried about that. But because to me, it doesn't really seem any different than like a Wago connector, and people love those. But feel free to talk about that in the comments, because I'm sure that's an unpopular opinion. I will say, though, that I myself have generally not used them, but a large part of that is because you can only use them on 15 amp circuits. On 12 or 20 amp circuits with 12 gauge wiring, you cannot. So that's a big part of it. But yeah, that's all that really this was about, was just we have tamper-resistant outlets now. A tiny little bit of progress has happened. But whether or not we're going to go further, not certain. I have said many times online, and I did not go into it in this last video because I just don't want to deal with it again, that for a large part, we get away with having bad outlets here because we only have 120 volt power. And then that always gets people arguing, 120 volts can still kill you. Yes, I agree with that, but it is for any given, this is what I have to say. This is how it has to be framed, because if I don't frame it extremely carefully, people get mad. Two things I learned over the last several years of being an online person. One, the word safer and less dangerous are synonyms to me. They are not to other people. So I used to say 120 volts is safer than 240 volts, and particularly non-native English speakers, I think that the word safer implies some level of safety. To me, it doesn't. It just means less dangerous, but that's a whole other thing. But the other thing is, yes, 120 volts can still kill you, but if you take a specific kind of shock and you look at all the different scenarios, voltage matters. So if we rig up an identical scenario and I get a 120 volt AC shock compared to 240 volt or 230 volt AC shock, one of them is a lot more likely to kill you, and it's the higher voltage. So yes, 120 volts is not safe. It is still plenty dangerous. But personally, I feel like the fact that our plugs are still this bad, we've never bothered to really change them, is evident that 120 volts, it takes many more. In order to be killed by an electric shock, a lot of variables have to line up. Let's put it that way. I think we can agree with that, right? Like breakdown or insulation breakdown, or the voltage required to cause insulation breakdown is going to change depending on, is your skin wet? What's the humidity? What are you standing on? What shoes are you wearing? You know, all sorts of things matter. And so you have, I don't mean to be morbid, but like to have an electric shock that kills you, it's like the Swiss cheese model. You have to go through a whole bunch of different things have to line up in order for you to be seriously hurt or killed. And lowering the voltage means more holes have to line up. So the clever thing about our system, as I've talked about with split phase power, is that you have a 240 volt device like a stove or water heater or whatever, but the wires inside of it are only 120 volts to ground. In order to receive a 240 volt shock here, you have to be touching both hot wires. So yes, I mean, like if you did that, very bad, because now you have 240 volts going across your fingers. But like if you brush up against a single wire in a US home, it's only going to be 120 volts. Even 240 volt appliances, every individual wire is only 120 volts respect to ground. They get 240 volts by one being plus 120, while the other is minus 120. So they're flip-flopping, if that makes sense. I didn't mean to really go on that tangent. I just wanted to put that out there, that the main reason I believe our outlets continue to be so bad is that, yes, you can be hurt by brushing up against an outlet. It has happened to me it has technically happened twice, but the second time it was on a GFCI circuit, so I didn't notice it. I was actually working on the jukebox when I was a little kid. I touched something and then the power went out. I didn't feel anything, but the GFCI outlet in the bathroom on the other side of the wall that the jukebox was plugged into was feeding the outlet that the jukebox was plugged into, so it tripped. And then the other time was I was, I don't know, 12, and I was doing a very stupid thing, and I was fumbling around in the dark, plugging a lamp in to a power strip, and I was actually feeling with, because it was dark, I couldn't see, I was feeling with my fingers to see where are the blades. I know, real smart. And then I got a shock from that. And I'm still here. So that's just what I mean, is that, like, it's not an ideal design by any means. And I'm not trying to defend it as being okay. I'm just trying to explain that we are granted an affordance by the fact that our general household voltage is lower. And that's all. That's all I want to say. Feel free to fight in the comments about how 120 volts can still kill you. I believe I've said that. It's just many more holes, many more things have to line up in order for it to be a lethal shock, or even, quite frankly, a harmful shock beyond just a surprise. So should we sleeve the plug and find a way to make it compatible with these? I would say yes. I'm pretty confident that we could. Like adding more bulk to the plug would not work, and you do have to deal with, you know, the main problem really is that we don't build any recess into it at all. So you only have the clearance of the depth of the face to the contact point to add that insulating material. Otherwise, that insulating material is going to come into contact with the contacts, and then it's going to wear out, or possibly even lead to bad contact, which could cause overheating in an outlet or even start a fire. So that's part of why I'm not confident that we can necessarily just do that without replacing all the outlets. And replacing outlets isn't hard. It could be done. We could definitely have some sort of a mandate that we're changing the outlet design. But given the way that, you know, this country reacts to things like that, I don't think it's going to go over well. So I do think we're largely stuck with it. The saving grace is, as I've already said, we don't have 230 volts phase to ground floating around. So long as you're careful. Well, I mean, that's the other thing. The design may be bad, but as I said, in my lifetime, I have been shocked once that I know of, and once that probably happened, but the GFCI outlet tripped. But at the same token, it may have tripped from low voltage leakage, because I was playing around with the jukebox. I don't know if I was actually messing with a high voltage circuit. It may have been one of the 24 volt AC circuits that bled through me, and then that tripped the breaker. I don't know. But does that work? Do GFCI outlets, because there's the thing about there are certain leakages they can't detect, but I think that would work because it's all AC. Anyway, I'm going to stop rambling now. That's really just all this video was about. Tamper-resistant outlets, they are a thing. They're not quite as good as I thought they were. And me saying yet again, which will probably get a lot, which people will not be happy about. The main reason our outlets are still so bad is because we can afford them to remain bad, because of all the ways people can be hurt by electricity, 120 volt shock plugging something in is low on the list, I believe. There are many, many more things that, and especially because, and I guess, sorry, still talking about it, when you are plugging and unplugging something, it is a conscious act, and we are taught as children, like, be careful with this. You need to, when we talk about risks of shock, reaching for a plug and holding it wrong really feels way, way, way down on the list to me compared to like there's a frayed wire that you didn't realize is there that you might brush up against. Or, I mean, that I think is actually the most common way people get shocked, I would imagine, is frayed wires, not plugging something in. But I don't really know. It's hard to look up numbers on this. I might edit a lot of this out. Anyway, I'm gonna for real stop the video now, and thanks for watching. Thanks for being here. I have a lot of loose ends that I want to tie up, specifically on connectors. There's so many things that like I've had on that I want to do, like the little red fridge is still here. I still want to do more experimentation with that. So that's all stuff that needs to happen, and I need to use this channel a little more. But right now, finding the time is a little bit difficult. But in this case, since this was a snip out from the script, I thought I'll just talk about it right now, right? I haven't even stopped the camera from recording the talking head. So anyway, see you around, see you later, see you next time. Thanks for watching.